Okay, let's do this again, just a little bit more quickly. So I'm reinforcing whatever you do. I would recommend that you hear one out and then you go do the next one or two and see how you did when you come back and watch the video. So definition of the period is to always take 2 pi, which is the period of the original sine and cosine curves, and divide it by the value that's in front of x, in this case 8. So 2 pi divided by 8. Please always reduce that. So 2 over 8 is 1 over 4. I'm just going to call that pi over 4 instead of 1 over 4. Then you notice that you have a sine curve with no number in front of the word sine, so the amplitude is 1. So you know you have a curve that starts right here, it goes up, it comes back down and crosses the x-axis, goes down, comes back to the x-axis, and that's the end. That's the period. So give me that spot. I'm going to go ahead and put the 1 for the amplitude and the -1 down below. I'm going to go ahead and cut pi over 4 in half, but I'm going to come up with an interesting thought in a minute. So pi over 4 in half is pi over 8. So again, notice that that 4 in the denominator could just be multiplied by 2, and then cut that pi over 8 in half to get pi over 16. Again, pi over 8, if you multiply that by 1/2, just the denominator gets multiplied by 2. And then to find this point, I want to make it a little bit easier. Each one of these sections is pi over 16 in length. So if I took this pi over 16 and added another pi over 16 to it, I'd get 2 pi over 16, which is 1 pi over 8. I already had that. I already figured that out by taking half of the pi over 4. But what's nice is that from here I go pi over 16 to 2 pi over 16. This next spot would be 3 pi over 16. Because I'm adding to the 2 pi over 16, I'm adding another pi over 16 to it. Remember, I'm adding this chunk, pi over 16, to this spot. I was at 2 pi over 16, so now I'm at 3 pi over 16, and if I do that again, if I add pi over 16 again, I'm at 4 pi over 16, and 4 over 16 is 1 over 4, and I'm at the end of this picture. So it's easiest actually to go to this quarter and add a quarter and add a quarter and then check to see if you're at the end of your last spot. Hope that made sense. I'm going to need to erase all of this now. So I'm going to take all of this right here and get rid of it. So hopefully you're okay with me doing that now. And of course go back. Let's look at the next problem. So the period is 2 pi divided by 1/3. By recording this for you, I can show you again division. So when you divide by 1/3, you multiply by 3 over 1, or just 3. So that's 6 pi. This is a cosine curve. It doesn't have a fraction, so it's a lot easier than dealing with fractions. Remember, a cosine curve starts up here at 1 and it goes down to the x-axis. Then it goes down again and comes back to the x-axis, and this is where it would start to repeat again. Back here I have to go back and fix this. I wrote 2 pi over 3 is 6x. I meant 6 pi. So let's fix that. And now the period of this function is 6 pi right here. Because there's no fractions, I'm just going to go ahead and cut that in half and call this 3 pi. And when I take 3 pi and cut it in half or multiply it by half, I have 3 pi over 2. So this spot right here would be 3 pi over 2. So just a reminder, 3 pi over 2 plus 3 pi over 2 is 6 pi over 2, which is that spot right here. 6 over 2, 3 pi. Add another 3 pi over 2 to that, and you get 9 pi over 2. That's this spot right here. 9 pi over 2 is that quarter point. If you added 3 pi over 2 to that again, they have a common denominator. 9 pi plus 3 pi is 12 pi over 2, which gets you to the end of the curve, which gets you to this period. So you can confirm that all your quarter points are correct. Don't forget, put that -1 down here. Again, pause, do one, and then come back and check and see how you did. So period here is 2 pi divided by 2 pi, because that's the coefficient in front of x. So it's 1. No fractions in this problem. This one's really simple. So the period for this cosine curve is 1. It starts up right here, crosses the x-axis, goes below, and this is where it finishes. This is where it will start to repeat again. So it'll go off and repeat again. So this is the period. That's equal to 1. You can call this 0.5 if you'd like, because it's just a decimal number, because this spot is halfway between here and here. This spot is halfway from here to here. So that's a quarter. And then you can easily see that that's 0.75. So sometimes no fractions involved at all. Let's keep going there. They should get a little bit more interesting, maybe a little bit more. Oh, I know what we're going to do now is we're going to add amplitude to the situation now. So now what I'd like you to do is I'd like you to state that the amplitude of this curve is 3. So this one's going to go up as high as 3 on the y-axis and as far down as a -3. The period is affected by this number 4. It gets cut into quarters. I take the original 2 pi period and divide that by 4, and that reduces to half of a pi. So, in an effort to try to show this a little bit more carefully, I'm going to cause this to go up here to where y is equal to 3. And down here where y is a -3, my sine, this is a sine curve, so it starts here, it goes up real high and then comes down and goes down to that -3 and finishes right here at pi over 2 radians, because that's its period. Don't forget, halfway would be pi over 4. Just take that 2 and multiply it by 4. Half of that would be pi over 8. So pi over 8 is the quarter amount. So to go from here to here, I have 1 pi over 8, 2 pi over 8, 3 pi over 8, and then to get to the next stop would be 4 pi over 8, and just check and ask yourself, is that this spot right here? Is that pi over 2? And I can go, yup, got my quarter points correct. Okay, let's now affect the amplitude by putting a negative sign in front of the cosine of x. So sometimes what I'll do is I'll say that the amplitude, because the book will say it's just 4, that's the height of the curve. But for my own sake, I'll use a color sometimes to remind myself that I have to go down, down below the x-axis, because my first output will be a -4 for this problem. So I just put that negative sign in there. 2 pi divided by the coefficient in front of x, which is 10. 2 over 10 is 1 over 5. Or just pi over 5, because 2 goes into here once and into there 5 times. So the period is pi over 5. Let's go ahead and draw this cosine curve. So cosine curve normally starts up here at 4. But this curve is going to start down here at a -4. And then just go ahead and draw the curve itself, and then come back in and put your quarter points in. So the period is pi over 5. So come halfway. Careful with the cosine curve, halfway is where it peaks out right there. So this would be pi over 10, because half of this would make that pi over 10. This would be pi over 20. Because half of this, take that 10, multiply by 2, pi over 20. This is 3 places over. So if this one is 1 pi over 20, then this one is 2 pi over 20, but we reduced it. And let me write that down for you. 2 pi over 20 is reduced, then this one would be 3 pi over 20, and then this one is the same thing as 4 pi over 20 because 4 goes into here once and into there 5 times. So I can check that as I go in these increments of pi over 20, 2 pi over 20, 3 pi over 20, 4 pi over 20. Let's finish this last one. So the amplitude is a -2. So I'm going to put that negative sign there. The period, so please write this as you do these problems. Write down the amplitude, write down the period. The period is 2 pi divided by 3 pi in this one. So the pi's are going to cancel out. So this one has a period without the value pi in it, but it's still just a number, 2/3. It's a sine curve. So when we go to draw this sine curve, we're going to not go up like this, we're going to go down like this. And then remember, it's kind of like noise cancellation. When I put that negative sign in front of it, if the sine curve was like this, I put the negative sign and it flips it upside down. So this is a -2, this is a +2, and the period is 2/3. This one, in the process of taking half of 2/3, I'm going to go ahead and do it right here to get to this spot. When you take half of 2/3, the 2's will cancel out, but go ahead and call it 2/6 if you'd like. You're welcome to do that. I just prefer to have you reduce it, so call it 1/3. And then to take half of 1/3 would be 1/6. Okay, cool. So that means from here to here is 1/6. This is another 1/6. This is another 1/6, and another. Let's check it out. 1/6, 2/6, 3/6 right here. I'm going to write it down without reducing it. This one would be 4/6. Is 4/6 the 2/3? Sure enough. And should I write that as 1/2? Absolutely. But if you don't and you wrote 3/6, I'm actually going to take it because I'm just so happy you got it. Sometimes people have a lot of trouble with this. This 3/6 is supposed to be written as 1/2 in its reduced form. We're going to come back and we're going to give you the period of the function and ask you to write the equation. It's called a game. What's my function? We'll have fun with it.